Good afternoon and welcome to the Middle East Teaching and Learning Conference. My name is Marijke Walters and I will be talking about dyscalculia. You will have the opportunity to ask questions on the Q&A forum on the app. So any questions you have, put it in there please, and I will try and answer them. So who am I? Let's get first things out of the way. I am Belgian and I'm married to a Brit and I live in England in South Yorkshire. So put all that together and that explains why I've got a bit of a strange accent. I was trained as a scientist, a cancer immunologist, and when I married my husband, we moved and lived on the east coast of Malaysia for 4 years. We then moved to the UK, and rather than continue with my science career, I became a secondary school maths teacher. So I've been teaching since 2006. I've worked in mainstream schools, I've been head of maths, I've been a maths consultant, I've worked with primary schools, primary school children and teachers, and I've worked in special education. All that still left me with a feeling that I still wasn't getting where I wanted to be with some of the children that really struggled. But I decided to leave school teaching and become my own personal private maths facilitator. So I now help families and individuals living with specific maths learning difficulties, one of them being dyscalculia. I also teach maths in British Sign Language because I'm a child of deaf adults, a coder. So, dyscalculia. I spelt it like that, and I've put the word in there phonetically because you might not have heard of it. I'd heard of it not that many years ago, to be honest, and I always thought it was a myth. It was people who weren't being taught properly, who didn't have good maths teachers in their day, and I would be able to help and fix these people. Now I know much, much better. I am going to show you a little clip of a boy called Toby, and that might give you a little bit of an idea of how hard the struggle is. So just watch this for a couple of minutes, please.
Doesn't automatically correlate to improving children's learning. Not all brains develop in the same way, and for some this can lead to quite specific difficulties with learning, such as dyscalculia, which involves problems with numeracy.
Count in twos for me and see how many twos we've got in on the table, how many groups.
Toby is dyscalculic. He's bright in all other subjects, yet a basic maths problem confounds him. He can't make the usual connections.
14.
15.
Nearly. 14.
16. 7.
18. 20. So 5 twos make
10.
Good. So we know we've got 5 twos under here. So what would be the next one? If 5 twos are 10, then 6 twos would be
12.
Good boy. It would be one group of 2 more. 10, 12. Excellent. If 6 twos are 12, we know we've got 6 twos under here. If 6 twos are 12, then 7 twos would be 10, 12,
13.
nearly 2 more, wouldn't it? 12,
14.
14. Good boy.
Professor Brian Butterworth is the leading authority.
It is hard to watch, I think, to watch that poor boy struggle as he is. And he's a boy who does well in all his other subjects, but maths, it's just impossible for him to get the grips with. So why is so little known about dyscalculia? Why have maybe you not heard of it, even as teachers? Well, when we look at the results, not long ago, I went onto the Chester University Library site and I searched for all publications to do with dyslexia, and I got 132,000 over results. We look at the same thing for dyscalculia, we have just over 9,000. So I thought, okay, this is maybe because all the research has been done in the last 5 years. So when I looked at the last 5 years, the publications on dyslexia brought up over 30,000 results and less than 3,000 results of dyscalculia. So there's more than 10 times the difference between what is known about dyslexia, what is known about dyscalculia. It's strange, really, because dyscalculia is not that uncommon if you think about it. There is about 5% of the population, according to research, 5% of individuals who are dyscalculic. So what does that mean for these children or for these adults? You know, you can read the child here. It says that, you know, she hates school. She just doesn't get it. She thinks she's stupid because she has to stand up, say the question, say the answer to the question. Couldn't do it, and the teacher said she hadn't been listening. It also happens with older children, like the boy here, also suffers with ADHD, which makes it even harder. And he finds it very difficult to process the numbers and write out the formulas. So does it get better when they grow up? Can we fix them by the time they become adults? Well, no, we can support them, we can enable them, we can give them strategies, coping strategies, but we can't fix it. These are two adults talking about their dyscalculia. So the one person says it's hard. It's not so much the fact that I can't do maths to save my life, but that nobody knows that it's actually something that can be diagnosed. So people think that she's dumb or lazy. But the other person, he said when he was asked what he would change regarding what's known about dyscalculia, he just wants people to be educated. And something that really struck me here is that he wants people to understand the shame that he feels struggling. It is, they do find it very shameful because people don't understand it. They don't understand that their self-esteem has been shredded by thoughtless comments. He feels different and excluded in a world where most people can grasp maths. But it's because people don't know about dyscalculia. So one of the things that I do is I work a lot with trainee teachers. I do talks on dyscalculia just to make people aware of what it is. With dyslexia, there is no single definition accepted of dyscalculia. Different countries, different continents, different researchers use different definitions. So I'm going to share 3 of the most commonly used definitions with you. The one is from 2001, so quite an old one now. I'm going to be partner for education and science here in the UK. I just want to point out a few things so that the definition says that these individuals have difficulty understanding simple number concepts, don't have an intuitive grasp of numbers, and if they do maths, they do it very mechanically. They've learned the process, there is no understanding. Another definition, and one that is used quite commonly in the research, is from the APA, the American Psychiatric Association. And they say, so similar, say that dyscalculia is characterized by impairments in learning basic arithmetic facts, also processing numerical magnitude and fluency in calculations. But interesting here is that they say it must be quantifiably below what is expected for that individual's chronological age and is not caused by poor teaching or by absence because of illness, by long-term absence, or by a child not being in school. So that's interesting. The definition we commonly use now in the UK is the definition that has been agreed by the BDA, the British Dyslexia Association, in 2019. So it's very, very recent. And the main thing here for me is the fact that it is now in a definition that it's got to be persistent. But I have lots of children coming to me, and parents say, oh, my child has got dyscalculia. Then I know for a fact that after that child has been working with me for a few months, that child is caught up. So that was not, of course, dyscalculia was not the problem there. The problem there was often maths anxiety and sometimes inadequate teaching. Important again here is that it's unexpected in relation to age and level of education. Like Toby, very bright little boy, can't do maths. The most severe thing is something called a difficulty with number sense, and we will talk about that in a minute. Number sense including subitizing, so we will talk about subitizing as well. But before we do that, I just want to share this other clip with you. And this person actually explains it really well. So I'm going to leave you with this professor for about 5 minutes, and then I will come back.
Specific LD in math. So what are some of the presenting problems that individuals will have when they have dyscalculia? Well, clearly in young children you will see difficulties with recognition of numbers and symbols. Just like in reading, children with LD have difficulties looking at identifying letters and matching them with sounds. Recognizing numbers and recognizing symbols in the math domain are things that learning disabilities present with in children with dyscalculia. There's a fluidity and flexibility with numbers that also presents in these children. Think about it as a number sense. They have a sense as to how numbers work, what they do, and there's a ease with which they move in the math, counting, what do numbers mean, how do we work with numbers domain. There's a piece of math and the math disabilities problems that we see in children that has to do with their ability to visualize. When you think about numbers or you think about quantity, most competent math users, all competent math performers, will actually have some sort of a math number line or a numerical number line, a mental number line, if you will, that they can superimpose upon their thinking. So they'll know, for example, that when you think about 1 and 2 and 3 and 4, that 4 is somewhere here and 1 is somewhere here. They see where numbers are in relation to each other. And children with learning disabilities in math, those with dyscalculia, often have difficulties visualizing what that math mental number line looks like and how it works. Counting is something that these children also struggle with. Not just in the counting of numbers, the 1, the 2, 3, 4, and 5, but the procedures involved with counting and the principles that underlie how it is that math happens and counting happens. They often have difficulty estimating and doing mental math. So if you look at a group of pennies on the table, they may have difficulty estimating how many there are on the table without actually counting them out. And doing that mental math, doing those kinds of approximations that help you get to an answer more quickly, those are things that children with dyscalculia, learning disabilities in math, will often struggle with. Measurement is something that becomes difficult over time, not just measurement in terms of length, the size of something, but also weight, looking at the area, approximating time and measuring temperature, and then certainly as they get older, being able to manipulate and measure using money. Working with numbers, often very difficult as students move into the early grades, not just adding and subtracting, but understanding how sets of numbers work. So how 10s work, how 20s work, how 30s work, how groups of numbers and sets of numbers and quantities relate to each other. Patterns, another area of weakness for many students with learning disabilities in math. So for example, the ability to count by 2s or count by 5s or count by 10s, being able to distinguish patterns in the ways that they use numbers in sequence. Something that's also difficult for many students with learning disabilities in math falls within the domain of spatial relations. These are individuals who sometimes struggle tremendously reading maps or following a route or even knowing left from right and finding ways to apply that left-right dynamic or that understanding in what is sometimes just a very simple kind of a way, even as they get older. And then certainly up through the middle school and high school grades, very often it's difficult for these students with dyscalculia, learning disabilities in math, to follow formulas. Very often they have difficulty scoring games. You know, a bowling alley, how do you figure out how to score bowling? Even sorting strategies if you have to organize things in a particular way. These are the kinds of things that we look for when we talk about learning disabilities in math. One of the other...
So, one of the things that he's going to talk about next is that for a lot of these children, this is causing a lot of anxiety as well. So anxiety is not just in math, but in their general school life, because everything is such a big struggle for them. Now, one of the things that people with dyscalculia really struggle with is called subitizing. I'm going to try and explain to you what subitizing means. Like if we look at these dominoes, then it's straightforward for us to see that that is 3 straight away. We don't even have to count that it's called subitizing. We can see that's 4. We recognize a pattern. We even know that that's 4. We know that that's a 9. We know 3 lots of 3 is a 9. That might be a learned pattern, but for us, that's not really difficult. For a person with dyscalculia, they will have to count how many there are. They will not see that here we have a 3 and a 3 and a 2, so we have an 8. So we're going to do a little bit of subitizing ourselves. How many did you see? I thought that you all knew there were only 3 counters on the board. So what about this? I'm sure you could see 4. Even they were not in a pattern, you knew there were 4 counters. What was that? 5. And we know that because we're very, very comfortable in seeing that as a 5, either through playing dice games or even seeing it as a 4 and a 1 or a 3 and a 2. Now, what about this one? A little bit harder. How many were there? Some of you will have counted in 3s or seen a 5 and a 4, but there were 9 there. So it's going to be a little bit harder, but we're still okay with it. We can still fairly quickly decide how many are there. Or we get, you know, a ballpark idea. We're not going to say there's 50 there, which is something else that people with dyscalculia really struggle with, is estimation. How many are there? Could you count them really quickly? This, you can't subitize. Okay, this is where we have to count. But that feeling of, how many are there, is a feeling that a person with dyscalculia gets when there's only a very few number of counters on the table. So, well, I'm going to show you some of the work that some of the people that come to me need to do in order to get a better understanding of their maths. So we do subitizing games here. We also do a lot of work with what's called concrete apparatus, or concrete things, big pebbles, big glass pebbles, things that feel nice. To make patterns, we use different colors. We make patterns for numbers. These patterns are consistently used in the same way. We play card games with them. Okay, so I won't go into too much detail, but as you can see, it's a very, very intense and a very slow progress. With subitizing. And now another thing that individuals with dyscalculia really struggle with is something called number sense. Like the professor was explaining, we have a mental number line in our heads, and depending on the way we write, that can go from left to right or from right to left. But there is consistency, and we know in our head where the number 0 is, where the number 4 is, where the number 100, where 3 million is. We know that that's on different ends of the number line. Children with dyscalculia haven't got that number sense. So they don't know that, you know, a 7 is a 2 and a 5 and a 3 and a 4 and a 6 and a 1 or a 0 and a 7. When I ask one of my students to write down the number 4,547, this is what she wrote down. When I asked her what 46 is, she said, oh yeah, it's easy, that's a 4 and a 6. So I said, well, draw me 4 counters and draw me 6 counters. She said, well, that's 10. So that was the basis to say, okay, let's see what we are doing. I wouldn't say what we are doing wrong, but let's see that there is, how can we fix it? How can I help you understand what 46 is? This child also didn't understand that 10, 11, 12, 13, that these numbers are made of 10 and some. So this is why some of these children struggle with what's called the teen numbers, that they don't know the difference between 14 and 14. Not necessarily because they can't read it and people think they've got dyslexia. No, it's because they haven't got number sense. They don't understand place value. So how can we help these children? For instance, I had another child here who I wanted her to explain to me what 34 meant. She said, yeah, 3 and a 4. So similar to the other girl. So we then counted out 34 counters, one at a time. She can do that. And then we said, okay, we'll organize those in groups of 10. Only then could we link that with other equipment. So we use a lot of equipment. We use Numicon, we use Cuisenaires, we use Beans. Again, as you can see, this is a very slow process. One of my other students did know that 10 was more than 5, or that 6 is more than 3, but couldn't tell you how much more without using the number line. Or she couldn't order the teen numbers between 10 and 100. As you can see, they are all over the place. But she could tell you that the sequence was 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There, I know it. She didn't. She can recite the sequence. That's something that we've got to be really careful for. The fact that children can recite this doesn't mean they understand it. We did a lot of work with teens, with equipment, which then ultimately helped her to get to grips with that. One of my other students really struggled with what the plus sign means, what the equal sign means. And again, we do a lot of work trying to understand, or trying to help them understand that. Now, what's causing it? Is it something that's happening in the womb? Is it something that's the child, has not had the right nutrients at birth or when they were little? Well, all we know at the moment with certainty is that it is actually something that happens in the brain. The brain of a person with dyscalculia looks slightly different to the brain of somebody who hasn't got dyscalculia. And the difference is in the white and the grey matter in an area called the intraparietal sulcus. So it's actually physiological. Neurological imaging studies have proven that. Because it's in that area, a lot of these individuals have got a problem with their working memory, which comes with lots of other difficulties. Is it genetic? Can it be inherited? The jury's not out on that one. Some researchers think they have found the marker. Other researchers do not always agree with that. So why is this an issue for you as a teacher? Clearly, it's just a maths issue. Well, like I said, I work with a lot of trainee teachers, and there was a whole group of them, all different subjects: English, PE, geography, humanities, all different subjects. And we came up with quite a lot of things which would be difficult for the children in their lessons. And if you're a primary school teacher, well, then you will see it, so many times, not only in your maths lessons, but, when you're trying to teach dates in history, or when the child needs to run up and down a track 5 times and has lost count, or the concept of time. These children don't understand, okay, in 10 minutes, in 15 minutes, in 3 hours, makes no difference to them. So there's a lot here that you could actually think about in your lessons. What would these children have problems with? Just think about the problem with left and right. It's a real issue for these children. How can you look out for it? So on this slide, there are some of the things, and most of the things we've already discussed today, but some of the things that you might think, oh, well, this is not what I've seen with the other children. For instance, if the child has got difficulty counting backwards, or has difficulty with place value, has got no idea whether the answers are right or nearly right, it's just shouting out random numbers just to get an answer, or avoids tasks that are perceived as difficult. These children will not even try something that they don't think they can do because they have failed so many times. And of course, they have very, very high levels of maths anxiety. So what can we do as educators? It is not easy. It is really, really tricky to help a child with dyscalculia. So what we do here at the Dyscalculia Academy is we don't only focus on the child. Obviously, we have a really intense intervention program with a child. Most of it is online. I work with children from all over the world, not just within the UK. I even have children in Russia, Germany, USA. So we're international. The way we work with a child is we use a lot of apparatus. We take it very, very slowly. We are very aware of the working memory overload for these children, and we repeat until the child has actually internalized it. Now, just working with a child isn't going to make all the difference. We also work with the teachers, with the support teachers, but also with the parents. So to help a child with dyscalculia, all the three groups have got to work together. Ideally, I know it's not always feasible, but ideally, everybody around the child is aware of it and helps the child to overcome this. When those three things work together nicely, then the child is able to access mainstream learning. The child can access it. In certain countries, these children are also allowed to have a times table square, to have a bead string. And for instance, in the States, where dyscalculia is officially recognized, that children or individuals can use a little basic pocket calculator in their maths exam, because they might understand, geometry and how it all works, but they might not be able to add 8 and 5 together. So that helps them. So this was a lot of information about dyscalculia. I really hope that you have got a little bit more of an understanding of what it is about and how hard it is for the children that you're working with, and maybe some adults that or even maybe yourself, maybe your own mathematical journey was really, really hard, and you might even have dyscalculia. So I understand that in this presentation, there's so many things I haven't touched upon to do with dyscalculia. So on there is my email. So it's info@mathssolutions.co.uk. So if you'd like to learn more about dyscalculia yourself, or if you know any parents who would benefit from more information, just tell them to drop me an email and I will help them as much as I can. I also have a website on http://www.mathssolutions.co.uk, and like everybody, my generation, I'm also on Facebook. So if there's anything that you would like to know now, any questions you have, you put them in the Q&A on the app, and I will try and get back to you as soon as I can. So for now, all that's left is for me to thank you very much for your attention. I know I've talked really fast, and I know I've given you lots and lots of things to think about, but I'm hoping it's been useful. So thank you very much, and enjoy the rest of the conference.